Hello, this is Professor Russo. In this lesson, we're going to determine why it was so important for us to learn how to factor, because now we're going to use factoring as a method to help us solve some equations that we never could solve before. Those that might be x to the second power, x to the third power. So we practice factoring not for the sake of just practicing it, but actually so that we could use it in things that are more important in algebra classes, like solving problems, solving equations, solving applications. So let's see how we solve equations by factoring. First of all, I got a couple warm-ups just to make sure you know how to factor. So when we look to factor this first expression here, we realize that it has two terms, right? And we also realize that we have some perfect squares, and we also realize that the powers are even. That reminds us of the difference of two perfect squares. We have the difference of two perfect squares. 3 gets squared to be 9. X gets squared to be x squared. And 5 gets squared to be 25. 1 with a minus, and the exact same values, 1 with a plus. So that we multiply the positive and the negative, we get the difference of two squares. Here we have 3 terms, so we're not using the difference of two perfect squares. We're using the idea that, well, the a is equal to 1. So I'm going to take a shot of saying if I can find two numbers that multiply to be negative 27 and add to be 6. So we know that we're going to start and set up the double parentheses, and in order to get x squared, it's x and x. And so we got to think of numbers that multiply to be 27. 9 times 3 is a perfect combination, because if I wanted to add to be negative 6, the negative goes with the big number, the positive goes with the small number, and we just practice two types of factoring questions. Now, let's talk about using that factoring to solve some equations. So in order to solve an equation with factoring, we have this property. You know, mathematicians got to get fancy with their words. They call it a zero product property, which means things that multiply product to be 0. So look at what the rule is down below. In order to solve an equation by factoring, we must use the zero product property. There it is right there. I'll put double stars next to it. And what it says is, let's look what it says algebraically. If a times b equals 0, then the a has to be 0 or the b has to be 0. What does that mean in words? If two numbers multiply to be 0, so if two numbers multiply to be 0, one of them has to be 0. So when I have two numbers multiplied to be equal to 0, either the first one, a, is 0, or the second one is 0, right? So if I had two numbers, let's change it, 5 and x, and they multiply to be 0, either the first number equals 0, well, it doesn't, it equals 5, then that means that the second number has to be equal to 0. So if the first one can't be 0, then the second one has to be 0. Many times we'll have two numbers multiplied to be 0, and usually when we think of multiplying, we think of those parentheses, and that also reminds us of factoring. So it says, if we factor a polynomial, we use the zero product property to find the solutions, to find the answers. So let's look at our first expression. Actually, it's an equation. I've got two things One of them is x minus 3, and the other one is x plus 5, and they are multiplying together to be equal to 0. The rule says either the first one is 0 or the second one is 0. And what we like to do is give all the possibilities for x. So we're going to solve this. Well, this is kind of easy, isn't it? If we do a plus 3 to both sides, can't we see that x equals 3? And if I do a minus 5 to both sides, can't I see x equals negative 5? So our answers are 3 and negative 5. Sometimes when you're doing the software in My Open Math, they tell you how they want those numbers written, usually with a comma in between. So you might want to get used to that. Let's look at the second example, which is the third example, example 3. So I have two numbers multiplying to be 0. That means what I do is I set each one separately equal to 0 and find what the x is in that little mini equation that we have. So we have two little mini equations, right? And maybe we can start checking and saying, wait a minute, I've got a plus 7. What do I need the plus 7 to be compensated for to get the plus 7 down to 0? And you might say, oh, that means you need a negative 7, because a negative 7 added to a positive 7 gives me 0. So you can see it's the opposite sign. Now here it's not so obvious. Let's do our math. Let's do a plus 5 to both sides. We get 2x equals 5. Let's divide both sides through by 2, and we get x equals, and we'll let it sit there like that, 5 over 2. So the first answer, we get negative 7, and the second answer, we get 5 halves. So the solutions, let's put yellow, the solutions for x is x equals negative 7, comma, 5 halves. And the first one, we didn't do it in yellow, but we see we got x equals 3 and 5. Example 4. We still have two things set equal to 0. Here's one, and they didn't put a parenthesis around 8x, but that's the second thing that's getting multiplied, because really there's a little hidden time sign in there. So we've got two things multiplied to be 0. They could have put a parenthesis around the 8x. Usually they don't unless there's an addition or subtraction sign. Look at the ones above. They had an addition, subtraction sign, so they stuck a parenthesis around them. But we got two things. The first one is 8x, and the second one is x minus 4. And together they multiply to be equal to 0. So we're going to say, well, what if the first one was equal to 0? And let's set the second one equal to 0. This one's easy. If I got a minus 4, I need a plus 4 to zap it out to go down to 0. And this one, I'm going to play it safe. I want to solve for x. I'm going to get rid of that timesing by 8, and I'm going to divide by 8, and I get x equals 0 divided by 8, which is 0. If you notice, you see that we already kind of did a problem like that. If I can draw your attention to green marker up here in the middle. We had 5x equals 0, and we said the zero product property says that means x has to be 0 if the first number is 5. Down here where we were, we have 8x equals 0. If 8's not 0, then the other one's got to be 0 if they're multiplying to be 0. So our answers are 0 and 4. Okay, now none of those we had to factor. They already were factored, weren't they? They already had the parentheses around them. That means they already were factored. So let's see how we solve an equation that's a quadratic equation where we have to do all the work. We have to factor it also. So let's go to the next page. In math, A lot of students like to say, what are the steps? What's the process? What do I have to do? Give me the 1, 2, 3, 4 so I could always get the answer right. Well, we do in this particular topic. Step 1 says, make sure that the equation equals 0. What equation? The quadratic. Remember our quadratics, right? ax squared plus bx plus c. We want to make sure it's equal to 0. Okay? And if we have to rearrange things to make it happen, we will. I'll give you an example. Then, once we're done, we want to factor that equation. So we have to set it equal to 0 first, and then we factor it. After we factor it, that means we got double parentheses probably, sometimes even 3 parentheses, but we're now going to use the zero product property that we just finished talking about on the previous page to find those equations and get their answers. Of course, you're supposed to check to see that they actually do work. Sometimes we don't really do that enough. So let me give you a very simple example. If I had x squared equals 5x. So now what makes these equations different than 095 math courses? We don't have x to the first. We've got x to the second, and sometimes x to the third. Okay. So, step 1, set the equation equal to 0. That equation isn't set equal to 0. We've got x squared equals 5x. I need to set it equal to 0. I'm going to rearrange. That means I'm going to take away a 5x from both sides. When I do that, 5x and minus 5x, there's the 0 I was going for. On the left, nothing combines together. I can't combine an x squared with addition and subtraction with a 5x. So there's my equation. X squared minus 5x equals, let's make it look a little prettier, equals 0. Okay. And now we did step 1. Step 2, factor the equation. What kind of factor am I going to use? I don't have the difference of 2 perfect squares because 5 is not a perfect square. I don't have 3 terms, so I can't go to double parentheses right away. The best I can do is say, I think I'm going to pull out the GCF. And the GCF between these two is x. And when I'm done, I open up my parenthesis, and I get x minus 5 after I factor. Step 2 is done. Step 1 was set it equal to 0. Step 2 was to factor it. Step 3, apply the zero product property. So I can look here and I say, oh, I got 2 things multiplied to be 0. That means either the first term, the x is equal to 0, or x minus 5 equals 0. Now, I already have the answer for the first one. I already know the answer. X equals 0. Here, I've got to add 5 to both sides, and my second answer is going to be x equals 5. There's my 2 answers. Okay. So once I apply the zero product property, I solve for x. Sometimes I can tell by just looking what it is. Sometimes I need to solve for it. So let's take a look at a few problems that they have here. First of all, they again did the work for you. Those are all factored. So we call those, kind of like the initial level, the first level, level 1. We want to solve for x. I'm going to start showing you some shortcuts here when we do that. So we can have x minus 6. I got 2 things multiplied to be equal to 0. Now, folks, do you see a pattern here? This one is a 6, and this one is negative 2. Because I need a negative 2 with a positive 2 to 0 out. And I need a positive 6 with that minus 6 to 0 out. Can we tell by looking here when we look inside the parenthesis itself, that if we have a -6 to make it go to 0, I need the +6. When I have the +2, can I see that I need -2? Can I maybe save myself a little bit of solving by knowing that rule? Let's look at the second example. Oh, I got 3 things multiplying to be 0. That means I'm going to get 3 answers for x. So the first one is set equal to 0. That's easy. That one's already done. X equals 0. Now the second one has to be set equal to 0. And the last one, the last what? The last factor is set equal to 0. Now the first one is already solved. One answer. X equals 0, comma. Now this one, I need to, it's not so easy. I can't really look. I want to add 1 to both sides. I get 2x equals 1. Divide by 2. I get 1/2 for x. There's my second answer. And on the last one, I'm going to take away a 5 from both sides. I got 6x equals -5. Divide by whatever's hanging in front of the x. I get -5, 6. And there are my 3 answers for those parentheses. Okay, so now let's get down to the work. This question says, solve the equation for x using factoring. Okay. So here's what we don't want to do. Oh, I think I'm going to, look, I can see I can pull an x right out of those two. I think I'm going to put an x down and open up a parenthesis. No. We don't factor until the darn thing is set equal to 0. It's not set equal to 0 right now, is it? So let me erase that for a second. And let's do this problem following the steps that you guys all like. So if we give you the steps, you might as well use them, right? So the first thing I need to do is I need to bring that +2, that -2 over to 0 out. So I'm going to do a +2, but once I do it to one side, I got to do it to the other side. Now it looks a little sloppy on the left. The nice part is that I get 0 on the right. And I'm going to put it in the standard form. So I'm going to put the x² term first. Then I'm going to put the 3x term in the middle. And now that new constant 2 is in the back, so that I have it in the standard quadratic form of ax² plus bx plus c equals 0. So step 1, I set it equal to 0. Step 2, look at your expression on the left, factor it. Okay, it's 3 terms, good chance double parentheses. It's got to multiply to be 2. Oh, well, that's easy. There's only 2 choices for that, 2 and 1. And now we got to get the signs right. It has to multiply to be +2 and add to be -3. The only way that works is 2 negatives. Okay? So that was the next step. Remember, first step, set equal to 0. Step 2, factor it. Good. Step 3, use the 0 factor property and tell me what x is. So we can see that x minus 1 equals 0. And the second equation, x minus 2 equals 0. So if I want my equations for x, I'm going to look right over here and I can see I need a +1. And I'm going to come over here and say I need a +2. There's my 2 answers for x. Many students stop short. They figured, oh, this is all about factoring. So I'm going to stop right over there. There it is. No, it didn't say factor it. It didn't say just factor. It said solve it for x. So in the end, I want to see x equals some numbers. Let's look at the next one. Step 1, set the equation equal to 0. Yay, it already is. I don't have to do that step. Notice on the first one we just did above, we had it set equal to -2. And we had to set it equal to 0. This one's all set for us. So the next thing says, okay, start factoring. Well, it's 3 terms. X and X has to multiply to be 48, and it has to add to be 14. So I got to write the right combination there. I think it's 8 and 6. And I got plus signs everywhere in that problem to factor. That means I got plus signs everywhere in my answer to factor. Now, I factored. Next step, use the zero product property. So that means x plus 6 equals 0, x plus 8 equals 0. Last step, solve for x in each expression. So here I need a negative 6. Here I need a negative 8. And there's my answers. Okay. And the last one on this page. Okay. Set it equal to 0. Yay, they did it already for me. All set. Step 2, factor. 3 terms, x squared, x and x, has to multiply to be 32 and add to be 4. Notice it's got to multiply to be negative 32. So I know one's plus and one's minus. And it's got to multiply to be 32, not 16 and 2, it's 8 and 4. 8 times 4 gives me a difference of 4. But the negative number is what dominates. The big number 8 goes with the negative sign. The small number 4 goes with the plus sign. And again, students just stop there and say, okay, all done. No, I want to know what x is. You factored it. Now use your zero product property. X plus 4 equals 0. X minus 8 equals 0. If you could do these in your head, all the better. 2 answers. Negative 4, positive 8. Last page. Okay. First step, set equal to 0. Done. Number 7, set equal to 0. Done. This step, I'm going to have to come back to question number 6 and set it equal to 0, and the same thing with number 9. So let's come back to 5. It's set equal to 0. I got to factor it. It's got 2 terms. Not 3, 2. And it's got a difference. And 25 is a perfect square, and 16 is a perfect square. So it's the difference of 2 perfect squares factoring. So I get 5x and 4, because those are what the squares are. 1 with a minus, 1 with a plus, 5x plus 4, 5x minus 4. I finished factoring. Now I got to solve it. So now the first parenthesis has to be set individually equal to 0, and the second parenthesis is set equal to 0. Now I could tell the answer, the number part's going to be the same. One's going to have a different sign, however. So when I do a plus 4 to both sides, I get 5x equals 4 divided by 5. The first answer is 4/5. Now, notice the numbers are basically the same except the sign is different. So when I divide by 5 this time, I get negative 4/5. There's my 2 answers for that problem. And I'm going to come down to number 7, even though it's out of order. But the reason why I'm doing that is because we notice it's 2 terms, just like number 5. So I get, let me rewrite it a little bigger. I got that beautiful thing. It's already set equal to 0, so I got a factor. It's got 2 terms. Wait a minute. The exponents aren't even. I don't have perfect squares like I did in the question right above. But I always have to remember before I start looking for all these special methods of factoring, I need to take the first basic method of extracting out the greatest common factor as my first plan of attack. And between 2 and 50, I can pull out a 2. And between x to the third and x, I can pull an x out. So there's my GCF. And now I'll open up a parentheses for the leftovers. When I do that, the 2 is gone. I started with 3 x's. I pulled 1 away. That leaves me 2 left. I put 2 into 50. Oh, there's my magic number, 25. I got to get that to go away. Not sure how to undo that. There we go. So when I put the 2 in the 50, I get 25. Wrong color. Okay. And I think I'm all done. I'm not. I have 2x, and the new parenthesis I just generated goes one more time. It's the difference of two perfect squares now, even though it wasn't in the initial question. So this is going to give me x minus 5, x plus 5 equals 0. And now I'm going to get my answers for x. You can tell me by looking here. I'll start in the back and go front. I need a negative 5 to take the plus 5 out to become a 0. In the next one, I need a positive 5 to zap out the subtraction of 5 to go to 0. And for this one, I have 2x equals 0. Two things multiply to be 0. If the first one's not 0, the other one's got to be. So I get 3 answers. Okay? So I got a 0 out of this one. I got an answer out of this guy. I got an answer out of this guy. And I got an answer out of the last one. Okay. Let's go to the last problem there, number 9. Let me erase so I can make some room. Let me get that out of the way there. Slow eraser. Okay, last problem. First thing, I can't factor it. It's not equal to 0 yet. So my very first move is to take away 48 from both sides. Now, that 48's not going to do anything on the left. It's a 0 here. But it doesn't cancel or reduce with anything else, so I'm just going to write it there. Notice I got it in standard form. The squared term up front, the plain old number in the back, and the x in the middle. And now I got to factor that. And I've got to see if I could pull a GCF out, like the previous question. And a 2 comes out. So I'm going to pull a 2 out of, oh, but that's it, no x, because there's no x in the back next to the 48. I could pull out a plain old 2, and I'll get x squared. I pulled a 2 out of 20, brings it down to 10. I pulled a 2 down out of 48, brings it down to 24. And now, I'm not done. I look at my new parenthesis, like the last question. It goes again. Now, I have to be careful. And bring that 2 straight down. And this here is going to go into double parentheses. X and x. Careful on 24. It's got to multiply to be negative. That means one's plus and one's minus. 6 times 4 doesn't work, because if one was plus and one was minus, it doesn't make a 10. But 12 times 2 is the right combination for 24. I get a positive on the 12 and a negative on the 2. There's my plus 10. So I'm going to put a plus sign and a minus sign. The 12 gets the plus sign, the 2 gets the minus sign, and now I'm ready to solve. Wherever the x is, so I'm going to start from the back. You can tell me. The answer is 2. You can tell me if I have a plus 12, I need a minus 12. And look at the difference between that problem and the other problem. I'll use yellow. Here, we had a 2 and an x, and it yielded an answer of 0. I don't have an x next to that 2. Don't say we're going to add 0 into the mix as one of our answers, only where the x's are. And since there is no x there, there is no number coming from that first 2. Therefore, these are our 2 answers. Okay. So once you finish this, you can go back into my Open Math, and you'll see some practice problems there that Professor Cockerham put together for us. And I will see you on the next time.